Trigonometric graphs. The sine and cosine functions are periodic functions, and they have a period of 2 pi. And this means that sine of some angle t plus 2 pi is equal to the sine of that angle t. And the reason for this is that if you are at some angle t here, when you add 2 pi to it, you add 1 full revolution, and therefore you end up at the same point. And of course, the y value there is the same at that point. Same thing goes for cosine, of course. And we can graph the sine as an analytic function by taking the distance on the unit circle from the point 1, 0 to the point here, and that distance t0 gets laid out on the x-axis. And then the sine of that value is just the y-coordinate of that point. And you can see that at the beginning here, when t0 is 0, the y-coordinate is 0. And as we move along the unit circle, the y-coordinate increases until it reaches a maximum value of 1 at pi over 2. And then the y-coordinate decreases down to 0 at pi. And then the y-coordinate goes to -1 at 3 pi over 2, and finally back to 0 at the angle 2 pi. And you can trace out those points here. So sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, and finally sine of 2 pi is back to 0 again. And this is the graph of the first period of the sine function. Now I say first period because after it goes through one oscillation, this oscillation simply repeats itself indefinitely. And so here we have a little more complete picture of that sine graph. So here is the first period of that sine graph. And then after that point, it repeats itself over and over again. And it does this, of course, in both directions. Now here we have that first period laid out on the axis here with the special angles highlighted. But the main thing you need to know is the basic shape of this first period of the sine graph. Now cosine is a little bit different. The first period of cosine starts up here at 1. And that's because on the unit circle, when you have t equals 0, the x-coordinate there is 1. And it goes through the same values, but it goes through them in a different order. And so the first period of the cosine graph looks like this. And down here you can see the special angles between 0 and 2 pi, and all the values of sine and the values of cosine. Now, what I like to teach my students is the so-called 5-point summary to graph either sine or cosine. And on these graphs, for the sine graph, you can see that 5-point summary by simply looking at these 5 points here. These are all the important points that you need to remember to sketch a graph. So we have, of course, all the points where it crosses the x-axis. Then we have its maximum value, and we also have its minimum value. Now on the cosine graph, notice that it has the exact same shape. It's just that it starts at the high point. So for the cosine graph, it starts at the maximum value. The first period ends at the maximum value. Halfway in between, we have the minimum value. And then halfway in between the maximums and minimums, we have the x-intercepts. And if you know these 5 points, and if you're able to sketch these 5 points, you can graph any translation of a sine or a cosine graph with ease. So how about sketching a graph of functions like 2 plus cosine of x or negative cosine of x? This doesn't require anything new. We know that if we have a graph of any function, so here is the cosine graph, if we add 2 to that graph, it's just a vertical shift 2 units upward, right? So now, instead of the cosine graph bouncing between 1 and -1, everything gets increased by 2 units on the y-axis, and so the maximum value is now at 3, and a minimum value is now at 1. And it bounces simply between those two lines. And then negative cosine of x is just going to be a mirror image over the x-axis. So again, here is the standard cosine graph. So negative cosine is just going to be the mirror image across the x-axis. We can change the so-called amplitude of the sine and cosine graph by simply multiplying the function by a constant. So first of all, what is the amplitude? Well, if you look at the blue graph here, this is the regular sine function. This is equal to y equals 1 sine of x. And the amplitude is 1, meaning that the high point is 1 unit above the x-axis and the low point is 1 unit below the x-axis. And so it bounces 1 unit above and 1 unit below, and this is what we refer to as the amplitude. So when we multiply sine of x by 2, that just increases the amplitude. Now that graph bounces between positive 2 and negative 2, right? And so the amplitude of that graph is 2. And if we multiply the sine of x by 1/2, let's say, 1/2 times sine of x, now the maximum value is not going to be 1, it's going to be 1/2. And so we can change the amplitude of the sine graph by simply multiplying the sine function by some constant value. So for example here, find the amplitude of y equals -3 cosine of x and sketch its graph. Well, we know that the negative is going to take the standard cosine graph and it's going to flip it across the x-axis, right? So y equals negative cosine of x would simply start down here, would cross here, would have a maximum value here, cross here, and then a minimum value here. And so that graph would look like this. And so y equals -3 times cosine of x is going to be the same as this graph, but multiplied by 3, and that increases the amplitude to +3. So the technical definition for the amplitude here is we take the absolute value of the number in front of the sine or the cosine function. And in this case, the absolute value of -3 is 3. So the amplitude of this graph is 3, but it also has a reflection because of the negative sign. We can also change the period of sine and cosine. So when you have a function y equals a times the sine of x, that's this black graph right here, we know the standard period is equal to 2 pi, meaning that after going through 2 pi units on the x-axis, it repeats itself. But if we multiply the x by a number, depending on whether that number is greater than 1 or less than 1, that is either going to shorten the period or lengthen the period, depending. So we can actually find the period by taking 2 pi and dividing it by the number b, which is the number in front of x if you consider y equals a times the sine of bx. The same thing is true for cosine as well. So both of these would have a period of 2 pi divided by b. And technically it's supposed to be the absolute value of b because it is possible for b to be negative, but that's a detail. So here we have a basic summary of what I just said. If you have the sine and cosine curves, y equals a times the sine of kx, or y equals a times the cosine of kx, assuming that k is a positive number, the amplitude is going to be the absolute value of a, and the period will be 2 pi divided by that number k. And so as an example, y equals the sine of 2x, the period here is going to be 2 pi divided by 2, which is pi. The amplitude, of course, is equal to 1. And so when sketching this graph, it's going to go between 1 and -1, but the period is now shortened. It's pi units. So it has to go through one complete cycle in pi units. So we know that sine starts at the origin. We know it's going to end at the same place. When I say end, I mean the end of the first period. And then it's going to cross halfway in between. And then, of course, we have high points and low points. And this is that 5-point summary that I referred to a little bit earlier. So once you have that basic graph, then it's just a matter of repeating that graph indefinitely. Over here, we have y equals sine of 1/2 x. So the period here is 2 pi divided by 1/2, which is equal to 4 pi. The amplitude is equal to 1. And so once again, it has a maximum and a minimum value of 1 and -1. But now the period is 4 pi. And so it's going to go through one complete cycle in 4 pi units. So it starts here at the origin. It's going to end at 4 pi. Halfway in between, it crosses the x-axis. And then we have our high point and our low point. And again, that is the 5-point summary. But you can see the drastic difference between these two graphs, even though the only thing that's different about them is the number in front of x here. One other thing about the sine and cosine functions is that the domain of all sine and cosine functions will be all real numbers. You can plug any number you want into them. And then the range is going to depend on this amplitude. So if we say that a is a positive number and a is the amplitude, then the range is just going to be all values between -a and +a. So a couple of other examples. If I want to sketch the graph of y equals 4 times the cosine of 3x, we know the amplitude is 4, and the period is going to be 2 pi divided by the number in front of x here, which is 3. And so if the period is 2 pi over 3 on our graph, that means every 2 pi over 3 units, we're going to go through one complete cycle. Now, cosine, the basic graph of cosine over here, starts at its high point, ends at its high point. Halfway in between, we have its low point. And then halfway in between those points, we have the x-intercepts. So on the graph, we know it's going to be up here at +4 when x equals 0. At x equals 2 pi over 3, which is the period, it's going to be at the high point once again. Halfway in between, it will be down here at its low point. And then halfway in between the high point and the low point, we'll have these 2 points. So once I have this sketched out, all I have to do is repeat that to get more of the graph. For the next one, we have y equals -2 times the sine of 1/2 x. So for this one here, the amplitude is going to be the absolute value of -2, which is 2. The period will be 2 pi divided by 1/2, which is equal to 4 pi. But we do have to note that this graph is going to be with reflection, meaning it's going to reflect across the x-axis. So our normal sine graph starts at the origin, ends over here at 0, crosses halfway in between, and then has high points and low points here. So when we're graphing our function, we know it's going to start at the origin. 4 pi units later, it's going to cross the x-axis again. Halfway in between, it will cross the x-axis. And then halfway in between these 2 points, it would normally have a high point of 2, because that's the amplitude, but the negative brings it down to -2. So that's this point down here. And then, of course, at 3 pi, we would have this point up here. So again, what you would do if you were graphing this on your own is you would graph these points first, and then it's very simple to sketch the graph through them. The sine and cosine curves can also be shifted horizontally. The way we do this is similar to how we would shift any graph horizontally, and that is by subtracting a number from x inside the function. So if we have y equals a times the sine of k times the quantity x minus b, or a times cosine of k times the quantity x minus b, assuming k is a positive number, this will have an amplitude of the absolute value of a period of 2 pi divided by k, and a horizontal shift of b units. So for example, if we have y equals sine of x minus pi over 3, notice that the amplitude is 1. The period is 2 pi divided by 1 here, which is 2 pi. So amplitude and period are normal. But the horizontal shift is going to be positive pi over 3. This is our horizontal shift. So that means instead of starting here at the origin, it's going to start pi over 3 units to the right. And every point on the graph gets shifted pi over 3 units to the right. For the other example here, we have 1 sine of 1 times x plus pi over 6. So amplitude and period are normal as before, but now the horizontal shift is negative pi over 6. So you have to take the opposite of the number that you see there. And that would be pi over 6 units to the left. So here's your normal sine function, sine of x plus pi over 6. Every point on that graph will be shifted 2 units to the left. So now, to give you a more complete example, find the amplitude, period, and horizontal shift of the following function here. So again, we know the amplitude is the absolute value of this number, which is 3. The period will be 2 pi divided by this number, which is 2 pi divided by 2, which equals pi. And we have a horizontal shift of positive pi over 4, right? We got to take the opposite of this number. And that means to the right, pi over 4 units. So to graph this, it's going to start at pi over 4, right? And it's going to be on the x-axis because that's how sine starts. And then if I go pi units to the right, right, because the period is pi, so pi over 4 plus pi is 5 pi over 4. That's where the first period is going to end. Halfway in between pi over 4 and 5 pi over 4 is 3 pi over 4. That's where it crosses the x-axis. And then halfway in between pi over 4 and 3 pi over 4 is pi over 2. This is where it will attain its maximum value, which is going to equal the amplitude. Amplitude is 3 in this case. And then, of course, halfway in between these two values, which is at pi, it will attain its minimum value. And here is the sketch of the first period horizontally shifted to the right of that graph. Next, I just want to show you an example of graphing on a graphing calculator. This is the graph of y equals sine of 50 times x. Now, let's just note very quickly here that the period of sine of 50x is 2 pi divided by 50, which is equal to pi divided by 25, which is a pretty small number. So if you try to graph this in a normal graphing window, because pi over 25 is a number that's much smaller than 1, you're going to get multiple periods. In this case, we have a bunch of periods between x equals 0 and x equals 10 here. And this doesn't give you a very good picture of what this graph is doing. So if I zoom in a little bit, if I reduce my window to -3 and +3 on the x-axis, you can see that we can begin to see the shape of this curve a little bit better. But when I really zoom in to values between -0.3 and +0.3, now you can really start to see the shape of this graph. And now it's really clear that the period is some number between 0.1 and 0.2. And in fact, if you actually do pi divided by 25 on a calculator, you'll see that this number is approximately 0.13. So when you're trying to graph something on a graphing calculator, your viewing window, your values of x and values of y that you want to look at are very important for getting an accurate depiction of the graph. We can graph sums of sines and or cosines using graphing calculators as well. So here's the graph of the function h of x equals 2 cosine of x plus the sine of 2x. I want you to notice that the graph does not behave the same as a regular sine or a cosine function. However, it is periodic still, right? So here we have the beginning of the graph, let's say, and you can see that after it goes through this phase of the graph and reaches this point, that repeats, right? So after this point here, you can see that this section of the graph is simply going to repeat over and over and over again. So these graphs are still periodic. The amplitude's a little bit trickier. So the amplitude of this graph is 2. The amplitude of this one is 1. But the amplitude of this whole graph is not 3. It's actually a little bit less than 3. So finding the amplitude can be a little bit tricky. We're not going to worry too much about graphing things like this by hand, but we can use graphing software to help us look at these things. Here's a couple other examples, graphing a function with a variable amplitude. So if I take a cosine function, for example, and I multiply it by x squared, I want you to notice how it is oscillating like a cosine function does, but the amplitude is increasing as you go in this direction, and it's also increasing as you go in this direction. And for the other one, we have the product of two cosine functions, and I want you to notice here how the amplitude behaves very erratically, right? There's really no rhyme or reason to it here, but you can see the amplitude is oscillating between multiple values here. So again, I would never expect you to graph something like this by hand, but graphing software can make this a pretty easy task. And finally, taking a look at graphing a function with what's called a decaying amplitude, and this is also called damped oscillation. And you can see what's happening here is as we move away from the origin, the amplitude is getting dampened, right? So it's decreasing. It's a decreasing amplitude. So sine and cosine functions that have other components, algebraic components, can change the amplitude, can change the period. And to graph these kinds of functions, we pretty much heavily rely on graphing software. And that concludes this video lesson.